Okay, so on the last group of problems, we are going to deal with factoring. The first thing is some vocabulary, an equation that can be written in the form ax squared plus bx plus c with a not 0. What that means is this number here is not 0. That's called a quadratic equation. Whenever we write an expression as a product, that would be like, think about taking the number 20 and writing it as a product. That's called factoring. The next one says the list of terms that's the product of all common factors. That would be your greatest common factor. Now, 51 is kind of interesting. It says a trinomial that is the square of some binomial. We actually saw this on 45 because this right here is the square, right? Square of a binomial, two terms. And when we squared that binomial, we got 1, 2, 3 terms. And that 3-termed trinomial is called a perfect square trinomial. So that is the answer to this one, a perfect square trinomial. I can go ahead and tell you that the next 2 questions will not be on the test, but it's leg and hypotenuse. But let's look at some of the next problems because they will be. So the next group of problems has to do with factoring, of actually doing that process of writing expressions as products. And so the first question you should always ask yourself is there a greatest common factor? Meaning if I look at these terms, which there's only 2 here, do these have a common factor? When I was a student, our teacher would make us take this and write it as, actually break it down into 2 times x minus 2 times 3 times x. And then we would circle, oh, they both have 2's and they both have x's. And then we would write that 2x as a common factor, and then we would write what we had left, which is x minus 3. Over the years, what I have decided to do for some reason is I like to think about it as just looking individually and going, what's the largest number? 2. And then for the variables, it's real easy. You just take the smaller exponent. And so now I know that what I'm factoring out is a 2x. And then I go back to my rules from before. Like if you look at that, that's 2 times x over 2x. Cancel, cancel, and you're left with x. Or you can simply subtract your exponents. Same thing here, 6x over 2x. Well, those divide out, and 6 divided by 2 is 3. And of course, that minus sign is just going to carry with it. And so that's how I've done it over these years, is I now just do this process, and I don't like the way that's written. I do this process where I, put it under here, figure out what my GCF is, and then I go, okay, that's what I'm going to write, and then I solve each one of these little problems here to figure out what my final answer is going to be. All right. So here, the GCF, here, there is no GCF on the next one. But what I notice is I have a trinomial, right, 3 terms, and it has the 1x squared, a number times x, and a constant. So what that tells me is I can just do a simple diamond where I put the last number on top and the middle number on the bottom. And so the question becomes, if I'm going to factor this, I know the x squared is going to break down into x times x. But I need to break down this 9 in such a way that when I add those 2 factors, I get a sum of negative 10. So if you think about 9, positive 9, you either do 1 times 9, negative 1 times negative 9, 3 times 3, or negative 3 times negative 3. And when you combine these, I get 10, negative 10 for that one, so that's going to be it. But you can go through and see like, oh, these are the numbers that are going to multiply to negative 9 and add up to negative 10. And so those 2 numbers would go here. Or the order doesn't matter here because you're multiplying. So either one of those would work. All right. 56, again, I look at that. Let me go back up here. 3 terms, and it's x squared plus bx plus c, and that's what tells me to do the little diamond. 56, there's no GCF, but there's 2 terms. And if there's no GCF and there's 2 terms, then I ask myself, is what I've got here a difference of squares? Meaning, do I have a squared minus b squared? Because if I do, then I can factor that into a plus b times a minus b. So the challenge here is, can I take 9 minus m squared? Can I write that as some value squared minus another value squared? And the answer here is yes. That's 3 squared minus m squared. And so now it's a matter of just fitting these values in their spaces. So instead of a and b, I have an m and a 3, meaning this would be 3 plus m and then 3 minus m. And so that is the answer. I'm going to write it in red, but that is your answer. 3 plus m times 3 minus m. All right, now 57, again, the question is there a GCF? And there is a GCF. Do you see how both of these have a plus 3? So if I were to divide out my a plus 3 from each of these, so just like I did up there with 2x squared minus 6x, how I divided out the 2x, remember that? Same thing. It's just here what I'm dividing out is bigger, or it's bigger looking. And so what I've got here is I've got a plus 3, and then what's left is the 9, right, because those divide out, minus, and then y. And so that's my answer. That's all I got going on there. Also notice, I don't know why that was so much bigger, or you could have done 9 minus y times a plus 3, right? I'm not going to do that anymore, but the order there is irrelevant because you're just multiplying. 58. Again, it's the same thing as what I have up here. There's no GCF, and there's 3 terms. And so what I'm going to be able to do on this one is simply say, what are the numbers that multiply to negative 36 but add up to negative 5? I know that it's going to be y and y. I also know that it's got to be a positive and a negative, right? Like it's either got to be that or that. It's either got to be 2 and negative 18 or negative 2 and positive 18. And if you think about it long and hard enough, you will find that 4 and negative 9 are going to be your numbers. So I'm going to have y plus 4 times y minus 9. Or again, y minus 9 times y plus 4. And so these two give you y squared. These two not only give you 36 when you multiply them, but they also give you negative 5 when you add them. So you can always check by FOILing. Oh, look at that. It already says no GCF on that one. How weird. There's no GCF, but there are 4 terms. And so what that tells me is to use grouping. So I'm going to group together my first 2 terms, and I'm going to group together my second 2 terms. And I'm going to factor out the GCF from each group. So the first group, I notice these 2 terms have a 2 in common and an a in common. So I'm going to factor out that 2a and see what I have left. So this right here, the 2's divide out, and I'm left with 1a. Here the 2a divides out, and I'm left with b. Of course, that's plus. Now I'm going to move to the next 2. And here's a key piece of importance here. Do you see that minus sign there? I need to make sure whatever this sign is here, I've got to use down here. So what I'm going to be dividing out is going to be minus, and in this case, the only thing 9a and 9b have in common is a 9. So what I'm really dividing out, or factoring out, I should say, is a minus 9, a negative 9. And so now, if you look here, what is negative 9 divided by negative 9? Well, that's going to be 1a. I just don't write the 1 there. And then here, negative 9 divided by negative 9 is, again, a positive 1b. I just don't write the 1. All right, so now I have grouped them, I have done their GCF, and then just like before, notice again that these both have a plus b, right? So I can take the a plus b and factor it out, just like I did on number 57. I'm just not going to write it that step. So some students do it this way. I kind of usually do it this way. I usually group my 2a minus 9 and then a plus b, but you could have switched them. That doesn't matter. All right, number 60. So again, I'm looking at this and I'm going, okay, there's no GCF. There are 3 terms, but this time it has ax squared, right? There's a number here. And so that's where I'm going to use Claudia's method. So let's remind ourselves what that is. So with Claudia's method, because I have the 5 there, I don't want it there. I want it just to have a 1 here. So I'm going to multiply the last number with that 5. And that's going to change me to have the problem x squared minus 16x plus 60. Meaning now I have 3 terms, or no GCF, 3 terms, and I've got a 1 here. So I can just do a simple diamond, and negative 10 times negative 6 and negative 10 plus negative 6. That's what gives me 60 and negative 16. You can always, list out all your factors. You can just, think about what numbers would be. If you cannot think of the numbers, then you need to sit down and do this. 1 times 60, 2 times 30, 3 times 20, 4, you might have to work it out, 15, 5, 12, 6, 10, 7, 8, 9. Those don't work. So I'm done. And when it's positive, you're adding them. And so these add up to 16. But in order to add 2 numbers and make it negative, they both have to be negative. So this is going to be x minus 10, x minus 6. I'm not done, though. That was for this easy problem. What I have to do to fix it is I have to come now and divide that 5 out from each one of these. So when I divide 10 by 5, I simply get x minus 2. Right? That's what I'm going to get here. But 6 over 5 is 6 over 5. It's reduced, and so because it's reduced and there's nothing else I can do to it, I'm going to move my denominator in front of my variable, and I'm going to end up with 5 times x minus 6. And so there's the final answer. And again, you can check it by doing first, outer, inner, last, and you should end up with 5x squared minus 16x plus 12. All right, 61. 61, it might look like what we just did, but notice there is a GCF here. The GCF, if I look at this, 4x cubed minus 44x squared plus 120x. So let's see, what do they all have in common? Well, they all can be divided by 4, and they all have at least one x. So that means I'm going to end up with 4x times x squared, right? Because look at there. Look at there. The 4's make a 1, and then you subtract 3 minus 1, you get x squared. 44 divided by that, that'd be 11, and x, and then plus, and then 4 goes into that 30 times. Are we done? Well, look inside here. Inside here, there's no GCF, but it's 3 terms, and it's 1x squared plus bx plus c, so that's a diamond. In this case, that's 30 and negative 11. And if you do your factors, you're going to find that 6 and 5, both negative, would give you what you need. So this can be broken down into even further. You still have the 4x, that's still part of the answer. That 4x just comes along for the ride, but now I'm able to break this down even further. That's number 61. So GCF check, but then I had a second type of factoring. All right, 62. So I look at that one and I think, okay, so there's no GCF, right? 4, 1, and 5 have nothing in common. So it's also, sometimes it's good to put that 1 there. So there's no GCF, there's 3 terms, and there is a number in front of that x squared, right? So that tells me to do Claudia's. So again, how did Claudia's work? Well, I'm going to go ahead and do that. Claudia's worked by multiplying the last number with the first number to make ourselves an easy little diamond problem. Meaning now I'm just looking what 2 numbers multiply to negative 20 and add up to 1. So again, if you're needing to do your factor trees or your factor list, if that 20 were positive, you would be adding. So if that 20 were positive, you would be adding, but our 20 is negative, which means we're subtracting. And so 5 minus 4 is 1. And so if it had been negative 1, then the 5 would have been negative, but it's not. So it's 5 and negative 4. So that means this is t plus 5, t minus 4. Not done, because I have to take care of my little trick of multiplying by 4, so I need to divide by 4. So when I divide by 4, I'm going to bring that up because 5 over 4 is reduced. So this is going to turn into 4t plus 5. And then this 4 divided by 4 is just 1, right? So that just becomes t minus 1. I think there's one more before we get to the solve. Okay, good. All right, 63. The only thing different on 63, guys, is that extra variable. But this is still going to just be, there's no GCF, there's 3 terms, and it's 1x squared plus bx plus c. There just happens to be a y and a y squared. So all that means is it's going to be xy, xy. But I'm still going to do a diamond. So I'm still going to do my diamond problem. It's just going to be that when I factor this, I'm still looking for what multiplies to negative 8 and adds to 2. It's just that it's going to be x plus something and x minus, or plus some number times y. And the reason why I did plus and minus is because it's negative 8, right? And so I think that would be a positive 4 and a negative 2. So it'd be x plus 4y, x minus 2y. So it's really no different. I mean, if you were to, take the y out, right, it would just be x squared plus 2x minus 8. So it's the same thing. And let's see. The next ones are solve the equation. So the first thing that you want to make sure of is it set to 0? So 1, set equal to 0, check. The second thing is factor. Well, here, check, because it's factored. It's broken down into x minus 6 times x plus 5. And then set each factor to 0 and solve. So everything's already done for me here. All I have to do is take x minus 6 to 0 and x plus 5 to 0. So x minus 6, well, I want to add 6 so that x is by itself. And when I add 6 to both sides, I'm just left with x equals 6. Here, I'm going to subtract 5 from both sides so that I'm left with x, in this case, equals negative 5. So if you just want to like list your answers as 6 and negative 5, that's fine. But 64 is awesome. It's already done. It's easy. 65 is not hard, but is it set to 0? No. So the first thing I'm going to do here is set it equal to 0. So to do this, you want to make sure that you always try to leave your x squared positive. And so to do this, I'm leaving space here, guys, for a reason, because I'm going to subtract 66 so that I get 0, but I have to do that to both sides. So now I end up with x squared plus 5x minus 66 equals 0. So the second thing I'm going to do is factor. So now I'm going to go and I'm going to think about what we just did on those other problems. And on this one, there's no GCF, and that's a trinomial with 1x squared. That's what tells me that I'm looking for two numbers that multiply to negative 66 and add up to 5. And so those two numbers are going to be 11 and negative 6. Again, I don't expect you guys to get those numbers that fast, but you find them out by thinking about what multiplies to 66. And you do 1 and 66, and you do 2 and 33, and you do 3 and 22, and 4 doesn't work, and 5 doesn't work, and 6, and then you find it. So you will get there eventually. It won't take that long. And if we did not have the equal 0, we would be done, but we're not. We have to solve this. So we set each factor to 0 and solve. So here I'm going to set x plus 11 equal to 0 and x minus 6 equal to 0. And so when I solve this one, I'm going to subtract 11, but when I solve this one, I'm going to add 6. So you just always either, if you're adding to the variable, you subtract to the other side. If you're subtracting, you add. And so negative 11 and 6 would be the solutions to 65. All right, 66, it's not set to 0. But not only is it not set to 0, notice that I would not only want to subtract 70 from both sides, but I need to distributive property this out. So this would become x squared minus 3x minus 70 equals 0. So I kind of did two things at once there. So I'm going to go back and do it one at a time if you need to see it. Technically, I would have done this first. X squared minus 3x equals 70. And then I would have said, okay, now that I have this, now let me subtract 70 from both sides. And now I've got x squared minus 3x minus 70 equals 0. So now I'm at my second step. So now I'm looking for two numbers that multiply to negative 70 and add up to negative 3. With much thought, I would think negative 10 and positive 70 would do the trick. I did that backwards. X plus 7, x minus 10. And now the third part of the process is to take each of these, because we've got that equal to 0, and set each little factor equal to 0. So here I would subtract 7, here I would add 10, and so my solutions would be negative 7 and 10. $67, a little bit challenging, but it's not bad because the first thing I ask myself is GCF. Because this is set to 0, right? So check. Check. So now I'm thinking about factoring. Well, I've got two terms here, so I can definitely do a GCF on this one because both of these have a t. So when I factor out the t, I'm left with 4t squared minus 81. Okay. So inside my parentheses, am I done? And the answer to that question is no, because inside my parentheses, I have two terms that can be written as a squared minus b squared. Meaning I can write this as 2t squared minus 9 squared. Right? Because those are the two things I'm squaring. So that means from the difference of squares formula, if you go back, that means I can do 2t plus 9 and then 2t minus 9 and set those equal to 0. I can break it apart that way because, again, with the difference of squares, you end up with a plus b, a minus b. And so here, all I did was I said, okay, that's 2t that I'm my first one, and then 9 is that. So now I'm done with my factoring. So my factoring is good. Now I've got to do the last step here, which is going to be to set each factor, which includes that t. So I've got to set the t equal to 0, the 2t plus 9 equal to 0, and the 2t minus 9 equal to 0. So for the t equals 0, I'm done. T equals 0, done. For this one, I'm going to have to subtract 9 first. And then after I subtract 9, I notice that I still don't have t by itself. So what I'm going to have to do next is divide by 2. And so when I get t by itself, it's negative 9/2. Take that off that circle. The only difference with this equation is I would add 9 first. And so after I add 9, I'm going to be lazy here. After I add 9, the only difference is that would be positive 9/2 when I get done with it. And so I was telling some students the other day that if you wanted to write your answer, like if you just wanted to write 0 and then plus minus 9/2, you can, because that literally means 0, 9/2, and negative 9/2. Let's look at 68. 68 is good to go. I mean, it is set to 0. So to factor this is the easy kind of factoring. 81 and 80. Oops. Negative 81 and negative 80. So when the numbers are off by 1, I usually try to think of the number in itself. So if I did these two numbers multiply to negative 81, and they do add up to negative 80. So it's factored, and now I just set each factor equal to 0. My hand is going to fall off. And so I end up with 80 and negative 1. So 80 and negative 1. Okay. And then 69 is not equal to 0. So that's the first thing I noticed. So the first thing I would have to do here is set this equal to 0. And you usually want to always try to make the x squared or the highest power stay positive. That's why I'm going to subtract 8x from both sides. So I have 15x squared minus 8x equals 0. So now I have to think, now that I've got it set to 0, now I have to think about factoring. Well, to factor this polynomial, there's only 2 terms. So I'm not going to be doing Diamond or Claudia's or anything like that. I'm going to first think about GCF. Is there a GCF here? And there is a GCF. And that GCF is just simply x. So if I divide out x from both of these, or factor out, then I would be left with 15x minus 8. All right, so now I've factored it. So now my 2 factors are x. So I'm going to set x to 0, and then I'm going to set 15x minus 8 to 0. And so x equals 0 is done. That's x equals 0. So boom. Then 15x minus 8 equals 0. So I would add 8 to both sides and get 15x equals 8. and then I would divide by 15. And so x equals 8 over 15. So my two solutions here are 0 and 8/15. Number 70 is going to be bonus on the test. So the bonus question on your midterm will be one like number 70. I will say this. If I go back and look at the homework number 9 solutions that I emailed you, on the homework number 9 solutions, the last problem is a lot like number 70. And if I look at the last set of notes I sent, the very last problem is also like number 70. So you have two examples that you can look at to help you figure out how to do number 70. Because the answer is in the back. And I believe the answer is like 15, 36, and 39. Meaning 15 is the shorter one, 36 is the longer leg, and then 39 is the hypotenuse. Also, I will say this. On your midterm, there will be 40 questions. 40 questions. The 10 vocab questions. So out of the vocabulary, I'm going to pick 10. Then there's going to be 30 questions. 25 will be multiple choice, and the other 5 won't be. They'll just be what's called open-ended or short answer. And so what I may do, so that's a total of 40. So what I mean by multiple choice and what I mean by this study guide is I may, going all the way back to the first page, let's see. So I may have a question like instead of finding C, B, or G, I might just use D or E or something. Instead of using these numbers, I might change the numbers. So it's just going to be a matter of just changing some numbers. Instead of, let's say, I have a good one. Instead of, like on number 59, instead of 9 minus m squared, I might have 16 minus a squared. Or I may have y squared minus 81. Those are all difference of squares problems. So out of the ones that are not vocabulary and not number 70, I'm going to pick 30 of them. So there you go. So good luck. You have my email. So get busy studying.